I wanted to make a video on this topic because although it's a really difficult topic, it's full of loads of other small topics that are really useful revision, so I'm hoping that overall this will be a really useful revision video. It'll go over a lot of key facts and key skills that are not as difficult as finding the equation of a tangent to a circle, but they're all involved in this process. They involve equation of a circle, calculating the gradient from coordinates, circle theorems in a minor way, but quite an important way, finding the gradient of perpendicular lines, so perpendicular gradients, and then generally finding the equation of a straight line using a gradient and a point. So each of those will be involved in this long process of finding an equation of a tangent to a circle. So the first thing to say is, we'll look at the question. T is the point 1, 5 on the circle with equation x squared plus y squared equals 26. So if you know about equations of circles, you'll know that all of these x squared plus y squared, which is the only time we see it at GCSE, x squared plus y squared on the same side of the equation tells us it's a circle equation. That is the radius squared, so the radius of this circle is the square root of 26. But you don't actually need to know that in order to answer this question. We are asked to work out the equation of the tangent to the circle at t, at this point 1, 5. The thing that you do need to know in order to answer this question is the center of this circle. And at GCSE, if you're given the equation of a circle, the center of that circle will be the origin, the point 0, 0. So we know that that point is the center of the circle, and we know that the point 1, 5 is on the circle. So 1 across, 5 up, and it's on the circle, so it must be about there. And I'm going to explain the process of finding the equation of the tangent to the circle. What we're doing is the tangent to the circle is the line that just touches the circle there. I haven't drawn that very well. See if I can do it better with a... Yeah, there we go. Just touches the circle there. Is a tangent to the circle, and we're going to be asked to find the equation of that line in the form y equals mx plus c. So a gradient and a y-intercept for that line. Now the way we're going to do that is firstly finding the gradient of the radius between that point 1, 5 and the center. The reason we need to work out that gradient is because using circle theorems we have radius always meets a tangent at 90 degrees. So that tells me that there is 90 degrees between this radius and this tangent that we're trying to find. So if I can find the gradient of the radius, I can use what I know about the gradient of perpendicular lines to find the gradient of this line. And then I will know the gradient of this line, and I'll know a point that it goes through, 1, 5, and therefore I'll be able to work out the equation of that line. So here's the whole process. Calculating the gradient from coordinates. We know that this line, the radius, goes through the point 1, 5 and the point 0, 0. So I'm going to start structuring my working by saying gradient of radius. And gradient, as we know, is the change in y variables over the change in x variables. So I'm going to say y2 minus y1 over x2 minus x1. Change in y variables, I've got 5 minus 0. Those are my two y coordinates, 5 minus 0. A change in x is 1 minus 0. Obviously you have to put them in the same order, so I'm using the point 5, 1 and the point 0, 0. That gives me a gradient of 5. So the radius has a gradient of 5. The gradient of the tangent is going to be perpendicular to that. And as we know, the gradient that is perpendicular is the negative reciprocal gradient. So that is minus 1/5, the negative reciprocal for perpendicular lines. That means we take the gradient, we flip it, put it under the fraction, and put a minus sign in front, or if it was a negative gradient, we would then have a positive gradient for the tangent. So we always use the negative reciprocal of the gradient we've got. So if the gradient of the tangent is minus 1/5, and this is the tangent here that I've drawn, I know that my equation for that line is y equals minus 1/5 of x plus c, because the gradient is always the m in that position. I now get on to this final section, finding the equation of a straight line. This line has that equation, and it goes through the point 1, 5. And this might be a question in its own right. What line with gradient minus 1/5 goes through the point 1, 5? Find the equation of that line. So if we're doing that, we take the y coordinate 5 and the x coordinate 1 and drop them into this equation, substitute them into this equation. The only thing we now don't know is the c, but we're going to be able to use these bits to solve and find out what c is. So 5 equals minus 1/5 times 1 is minus 1/5 plus c, solving to get c on its own. So I'm going to add 1/5 to both sides. 5 and 1/5 equals c. So I know that this was the equation of my line, but I didn't know what c was. Using the points that it goes through, 1, 5, I've substituted those values in, and I've found out what c is. Remember, this line y equals 1 minus 1/5 x plus c could represent any line with that gradient. So any of these lines could be minus 1/5 x plus c, because they all have a gradient of minus 1/5. But if I want the specific line that goes through that point, that's why I use this point and y equals 5 and x equals 1 to do that. So I found out that in this case c equals 5 1/5, therefore my equation for this line is y equals minus 1/5 x plus the c that I now know, 5 1/5. Don't know why I wrote 1/2, 5 1/5. That could also be written as y equals minus 0.2x plus 5.2. Okay, so I'm going to use one more example. I said at the beginning that any circle that you're given the equation of at GCSE will have its centre at the origin, the point 0, 0, and that's really important. However, because we don't need to know much about equations of circles for this particular type of problem, they can give us a question like this where the circle has a different centre. We don't need to know the equation of this circle, we're just asked to find the equation of the tangent in this question. So this says a circle has centre 2, 4, and the point P 513 lies on the circumference of the circle. So doesn't matter where I draw it, 513 lies on the circumference of the circle. Find the equation of the tangent to the circle at P. So again, I'm thinking about this tangent line. That's a bit steep. Tangent line, which is going to be at 90 degrees to that radius. So the first thing I'm going to do is work out gradient of radius using those coordinates. And that is change in y over change in x. So I'm going to take that as my y coordinate, 13 minus 4, the other y coordinate, over 5 minus 2, the 2x coordinates. 13 minus 4 is 9, 5 minus 2 is 3, 9 divided by 3 is 3. So the gradient of the radius is 3. I need to find the gradient of the line that is perpendicular to that radius, so I find the negative reciprocal. Gradient of tangent equals minus 1/3. So knowing that the gradient of that line is minus 1/3, that tells me that the tangent equation takes the form y equals minus 1/3 of x plus c, which I haven't worked out yet, but I also know that the tangent goes through the point 513. And that again tells me that I can substitute 13 in for y. I've still got this minus 1/3. And when I substitute 13 in for y, I substitute 5 in for x, and then I put a plus c on the end. So 13 equals minus 5/3, minus 1/3 times 5, plus c. Getting c on its own, I add 5/3 to this side, that is 1 2/3, so that is 14 2/3 on this side, equals c. And that tells me the equation of the tangent is what I had here, but now I know what c is. So y equals minus 1/3 of x plus 14 2/3. And that's the equation of the tangent to the circle at B. So main things to think about there are, could you do that final process, finding out what the plus c is, finding the equation of a straight line from 2 points. Sorry, not from 2 points, from 1 point and a gradient. Can you find the equation using the gradient and a single point like the point 1,5 there? The other thing that you need to think about is, could you do the first step and just find the gradient of the line that goes between the center and the point on the circumference that you've been asked about? That's the gradient of that radius. Because if you can do some of those things, then you can get some points off a difficult question like this, even if you can't get entirely through the question. Okay, I hope that was some help. That's it for now.